Okay, so structure diagrams. Yesterday we talked a bit about the program development lifecycle, right? So when we talked about the program development lifecycle, I told you guys about the design stage, which basically means that we kind of create an outline of the software. Okay. Now, structure diagrams, they're just a way of representing you can say a product structure. You can say a product structure. How does it work? It basically uses boxes to define modules. Now, I told you guys, I gave you guys like a really good example yesterday. I gave you guys an example of ChatGPT, for instance. Let me just okay. Let's talk a bit about structure diagrams. So they look okay. So structure diagrams, you have boxes, right? And these boxes, they what do you say? These boxes have the module names. So like for instance, if I were to create Rick GPT, okay. So this is like the first module, the main module. Okay, this is like the main module. This further gets divided into, let's say, multiple more modules. So there's the interface, then there's the there's the interface, then there's the backend, you can say, right? So and then these can get further divided. So for instance, in the interface, I can say that I need a website, right? So I can go like so I can further divide interface into okay oh man, that's crazy. Okay, so I can further divide interface into website or into mobile app, right? So mobile app, and I can divide backend into, for instance, into something like the AI part itself, storage of data, right? So storage of chats, storing chats, and so forth. So there's the main module, then there's their submodules. Okay, so these all work by drawing arrows to them. So there's an arrow drawn right over here, then there's an arrow drawn right over here, and similarly we just bring this over here. Okay, you don't need to worry about the terms. I'm just showing you guys the syntax on how you draw structure diagrams, so it looks something like this. Okay, don't worry about the keywords yet. We'll go over more into this in the past paper, but this is how you basically draw a structure diagram. You have the main module, and then you have submodules going down and down and down and down. Okay, so they're gonna give you some real world example, and they're gonna be like create a structure diagram for this. So for instance, they could say something like create a structure diagram for an alarm clock. So if we're creating a structure diagram for a digital clock or an alarm clock, we can like we're gonna light a main module, we're gonna give it a name, so we're gonna go something like digital clock, and then we're gonna further divide this up into parts. So it's a bit of logical thinking. You wanna know what what a functionality of a digital clock would be. There would be something like for instance, there would be something like the clock itself, right? Let me just so there would be something like the clock itself. There's gonna be something like the date fetching, so in order to getting the dates, right? So then there's gonna be like maybe something like stop a clock. So you don't have to worry about the keywords. Stop clock. So you don't have to worry about the keywords. All right. If your idea is correct, then you're gonna get the marks. All right. But if they have specified that the app has this submodules, then you're gonna write those submodules. Okay, if you don't write those submodules, then your marks are gonna be correct. So like for instance, if it says something like create a digital clock for an app, and this digital clock would have a clock, and it would have a date fetching, it would have counter, it would have stopping the clock, etc., then in that scenario you're gonna need to make your structure diagram similar to the question that they asked. Okay, so that in that case you'll make it similar to what they asked. So clock can be further divided into like the hour, minutes, seconds, right? So hour, minutes, that's just something like okay, minutes and seconds. So if you just think about an alarm clock or like any kind of digital clock, you'll see that there's like the hour. It's just an alarm clock. I don't know what to explain more about alarm clocks, but you'll see like it usually has time written in some format. Like for instance, it has time written in the format of 7, 28, 32. So 7 hours, 28 minutes, and 32 seconds. But that's basically what a structure diagram looks like, right? So you have a main module and you divide it up into sub modules. So let's just finish this. So date, you could have something like month or day, right? So month or day, and we're gonna add arrows over here as well. And for stop clock, you could have stopwatch or stop clock. You could have something like seconds. Okay, so it's just the working of how an alarm clock works, right? So sorry, how a digital clock looks like. And yeah, that's basically how structure diagrams work. They'll usually give you context in the question, but if they don't, just trust your intuition, they'll give you marks for that. So let's just copy this and just paste this over there. So you just use boxes, don't make them curved like I did, that's just the software. You just use boxes, it doesn't matter either way, but you just use boxes, and you use these boxes to define different modules of the program. Okay, so let me just copy this and paste it over here. Okay, so that's basically what structure diagrams are. Make boxes of modules, name the modules, and divide that up into further modules. Okay, so after this you have pseudocode. You have the three other types of things that we talked about. All right, we have three other things that we talked about in the design section. These are flowcharts, pseudocodes, and algorithm, right? So when we talk about algorithms, these are just steps taken to solve a problem. Okay, you can write it as steps taken to solve a problem. Now, an algorithm is something like, for instance, if I were to close my door right now, my room's door, I would need to get up, I'll need to walk down, I'll need to go to my door, and then I'll close it. So an algorithm for that would look something like get up, walk down, walk towards door, close door. It's a series of steps that we basically use to solve that we were using to solve like a different problem that we have a task on hand, right? So that's basically an algorithm in order. All right, so remember, an algorithm will always be in order. So it's not going to be like I close my door, then I somehow magically go down, and then I magically walk backwards, and so on and so forth. It's going to be in order. Okay, the other thing is flowcharts. Now, flowcharts is a way to diagrammatically show the steps required to complete a task. Okay, so diagrammatically steps to complete a task. So for instance, if we forget about programming real quick and let's just think theoretically, all right, let's just forget all syntax and whatever. A flowchart would look something like this, right? I would have for the same task at hand. Okay, so the first step would be getting up from my bed. The second step would be the second step would be walking down, right? The third step would be walking towards door, walk towards door. The fourth step would be close door, right? So this is just a basic algorithm for me to get up and close my room's door. So this is how a flowchart would look like. Okay, it's a series of steps that are in flow. Okay, so that's just generally speaking what flowcharts are. Now for our syllabus, there's a specified syntax that we need to make sure of. So whenever we're gonna start a flowchart, it's always going to start from a rounded rectangle or an ellipse. All right, so it looks something like this. Okay, so we're gonna mention that it's the start and it's the end. All right, so you have to remember that in our syllabus there's gonna be what do you say, end. All right, so in our syllabus there's gonna be a start or an end. Okay, so that it's gonna be an oval that looks something like this. Okay, so we're gonna I'll just copy paste this into the theory notes as well. So there's going to be a start and an end eclipse. Okay, that we're gonna use to specify that our algorithm is starting or our algorithm is ending. Now, what do you say? Now, in order to mention the steps, we use something called flow lines. Flow lines are basically something like an arrow that go from one step to another step. Okay, we call these flow lines. So something like this. These arrows that I'm drawing, they're basically what flow lines are. Okay, so pretty simple. So far, it's just a bunch of arrows. Okay, now the second thing is input or output. Okay, now obviously if we are gonna if we're gonna talk about a proper a proper flow chart, it's not gonna look something like this. So I'll just create a different flow chart. So let's say that the task at hand is something like let's say the task at hand is something like I want to input a number. Okay, I'll write this down as well. So task is that input a number, check if it's greater than 5, if true, output your weird. Okay, so this is a basic algorithm. Okay, we're just gonna see this is a basic task. We're just gonna input a number and we're gonna check to see if it's greater than 5. Okay, so what this would look like is, like I said, there's gonna be a start and an end. Okay, and there's gonna be flow lines. So when we talk about flow charts, there's a method of input. So let's think about how this would work. The first thing that we would do, like algorithm wise, a rough sketch, we're going to do something like let's think about it. So the first task would be to input the number, right? That would be our task number 1. The first thing that we're gonna do. The second thing we would do is check if it's greater than 5, right? If it's greater than 5, output your weird. And then we just end the algorithm. So it's basic. We just made it smaller into steps. This is also decomposition, right? We just took the bigger problem and we made it smaller. We made it into smaller different tasks at hand. So if we look at this, so in our syllabus, to represent input and outputs, we have something called a parallelogram. Okay, so it looks something like this. Okay, so this is used to signify inputs and outputs. So for instance, if we wanted to input a number, it would look something like this. So we would write input number. Okay, so that's what it would look like in order to input a value. All right, that's the first step. Okay, that's the first step. Okay, so we just did the first step right over here, which is inputting the number. The next step is to see if this number that we just input, if it's greater than 5. So we're gonna first of all create another flow line that goes into the next step, and we're going to create a decision box. The decision box, it's basically going to be a diamond. Okay, and now this diamond is gonna have a text. Okay, so this text would be something like is num greater than 5. Now this diamond box, it will have 2 possible outcomes, right? There's the true outcomes, then there's the false outcomes. Okay, every condition has a true or a false outcome. So let's just say that this is the place where it's gonna go for the true outcome, and if it's false, then it'll just directly end the algorithm, right? Because there's nothing to do if it so we know that if it's greater than 5, we're just gonna output your weird, and if there's nothing to do, then it just ends. So let's just bring this up here a bit so that it doesn't look that way. So let's just so it'll just end if it's nothing, and it'll output your weird. So in order to output, like I said, we use the parallelogram, and the only thing different from this the only thing different would be just a sec, let me just copy this. Okay, alright, so we're gonna use the parallelogram, and instead of writing input num, we would output your weird, right? So we're gonna output your weird. So that's how an output would look like. Okay, you can also output variables, so you just do something like output num if you want to output the number, or but in our case it's just a text, so we're gonna output your weird. All right, so that is going to be step number 3 done. The last step is to end the algorithm, so we're just gonna draw flow lines. So if what do you say? Okay, so if it's false, you should also mention the no and yes part, so you need to mention with the flow lines what happens. So for instance, we said that if it's greater than 5, then we're going to output your weird, so we're going to write yes over here, output your weird. And if it's not, then we're just going to directly end the algorithm. And after it outputs your weird, we're also going to end the algorithm. Okay, so we're just going to draw like 2 flow lines that just go over here, they just end up ending the algorithm. So it's a basic flow chart. Okay, it's a basic flow chart, nothing too complex. Mostly in the exam, questions related to flowchart, it would be to create the flowchart, right? And they'd tell you what steps, so they'd give you like something like a task at hand. I suggest you divide it up into tasks just like I did over here, and then you make the flowchart for those tasks. So in the case of flowcharts, you have the start and the end symbol, which we already talked about. So I'll make a separate thing right over here. So there's a start symbol and then there's the end symbol. These are used to specify the start and ending of the algorithm. So at the start of the algorithm, you would write the start symbol, and at the end you would write the end symbol. Then there's the input output scheme. So let me just, okay, input output. So there's the inputs, right, and then there's the outputs. Both of them again use a parallelogram, so the input would be something like input x and output would be something like output x. Then you have the decision box, so it would be something like is condition, right? So the condition could be something like is x is equal to 4, is x is equal to 5, whatever. Okay, so that's condition. So is condition. Then you would what else do you have? You have process. Okay, process. Now process, it's a bit funny, so let's do process as well. Let's modify our algorithm for another step. Okay, so we'll talk about what a process is. So let's just say, okay, I want to that there's a new task. Okay, it's the same as the old task. It's the same as the old task, except this time the only twist is that if it's false, increment it. If it's false, make a variable called x that has the value false. Okay, so it's a bit different now. Okay, we're just gonna create a variable, a new variable. Okay, so what do you say? All right, so let's go over here. So right over here we already have this algorithm made for the other steps. So if we break this task down, this would look something like the same as the last one, except if it's less than 5, store false in x, right? So the only thing that's different is we're gonna add a process right over here. Now the process, let me just delete this. Let's just move this down here. All right, so the process is basically used to assign variables, mainly used to assign variables, right? So what we would do is we would do something like x is equal to false. Okay, now it doesn't really have much use. I just wrote that to help you guys understand a bit on what this is, but yeah, that's right over there. So that's basically what processes is. It's mainly used to define variables. So no, okay, so that's what a process would look like, right? Now let's make it a bit more complicated. Let's use loops. Okay, so let's use loops. All right, so let's make it a bit more complicated. Let's count the number of 5s that are input. Okay, so the new task is something okay, the new task is something like if it's, then create a variable called x. Let's remove this. All right, input multiple numbers, check if it's greater than 5. If true, output your weird. If false, increment a variable, if false, count all false attempts, repeat inputs till -1 is input. So I'll better phrase this for you guys as well. basically what the task is that we're supposed to input numbers continuously until the input number is -1. At that point, we're just going to end the algorithm. Okay, and we're supposed to count the number of times that a number that is less than 5 is input. So how would we go about this? This is a way more complex thing. Okay, so the first thing, of course, is that we would start off the algorithm. Okay, so it would be start. Now we're going to create a flow line and we're going to run the first process. Like I told you guys, the first step is to assign, what do you say? The first step, the way to assign variables is in a process. Now we know we're going to count the number of, we're going to count the number of times that x was, that the input number was less than 5. So we're just gonna do something like okay, count is equal to 0, because at the start there's gonna be no variables input. Now what we're gonna do is we're going to input the number. Okay, so I'm just gonna copy this from here. All right, I'll just copy this from here. Oh my god. Okay, copy, paste. Alright, so we're gonna input the number. Now we're gonna deal with this number for a sec. Okay, so now the next thing is okay, I'll also divide this into further steps. So this would be something like we're gonna initialize the variables, right? Initialize variable count. Okay, that's gonna be the first step. Input number, which we just did. Then you're going to check if number is -1. If it is, end the algorithm. If it is not, check if it's less than 5. If it is, output your var. If it is not, increment by 5, repeat. Right? So it's a bit more complicated. Okay, so we're just gonna go back. We're just gonna create this, and you guys will understand the concept better as well. So we just did input number. The next step is to check to see if this number is equal to -1. So we're going to create a condition, and this condition would be is num equal to -1. Okay, and we're gonna draw a flow line that goes from num to -1. And if it is -1, then we're just gonna end the algorithm. So I'll just make a little end symbol on the left. Okay, I'll just make an end symbol on the left. And if it is not equal to -1, then we're gonna move on to the next thing. Now remember, when you're doing decision box, you're going to specify the conditions as well, the yes and no's. So yeah. Now the next step is to see. If it's not, then check if it's less than 5, right? So we're gonna create another decision box, and this decision box would be is num less than 5. Okay, now remember, we have two possibilities. The first possibility is that it is less than 5. In that case, we're supposed to output your var. So we're gonna I'll just copy this again, the input output box. So we're just gonna do this, and I'll just be like output your var, right? So that's gonna be the yes condition. You should also mention this right over here. All right, yes condition. And if it's not, then we're going to increment the count variable. So we're just gonna do count is equal to count plus 1, right? And we're just gonna add another flow line, and we're just gonna specify that this is the no part, right? So no. All right. So that's basically what that is. And now the next step is to repeat this, right? So what do you say? Okay, so in order to repeat this, we just take these flow lines, and we just take these flow lines and we just take them back to the point from where we want them to repeat. So for instance, I want them to repeat every time that we're inputting a number. So I'll draw these flow lines that basically take me all the way over here. Okay, and I can just make this flow line go over here as well. Okay, so that's basically how this algorithm would look like. It's better to use lines over here, but again, doesn't really matter that much. I'll just use lines. Okay, so lines, okay, doesn't really matter, but OCD. Okay, so this is what that algorithm would look like. Now in the question, they didn't specify, in the task they I didn't specify that you need to output it, right? So I just made it count. But if you wanted to output it, if it is end the algorithm and output, right? So if we wanted to output it, then it would be something like before we end the algorithm, we would add an output thingy to it. So we would do something like Control C, Control V. Okay. So it would be something like we add another input output box, and we would write in this input output box, we would write output count, right, to output the number of times that a number less than 5 appeared, and then we would end the algorithm. So it's a basic flowchart. You should know how to draw stuff like this, right? It's a very popular question. Not obviously this one, but like just generally speaking, drawing flowcharts. So that's how a flowchart works. Okay. Now the next, any question from flowcharts? Any questions from flowcharts? Why the hell are you guys being dang creamer in chat, bro? That's crazy, bro. That's crazy. Okay. So any question from flowcharts? Anything confusing at all? Right. So okay. All right. So moving on, we have pseudocode. All right. So like I said at the start when we did the poll, I asked you guys if you wanted to speed run if you wanted to go in depth, or if you wanted to speed run past paper. So we're not gonna go in depth. We're not gonna talk about pseudocode. We're not gonna learn pseudocode from scratch. We're gonna focus more on the past paper. So I'm assuming that all of you guys know pseudocode already. So let's just do the more theoretical parts of pseudocode. Okay. So when we talk about pseudocode, there's a few things that we have to know, and these are the variable and constant definitions, for instance. So in the case of a variable is just storing data, right? So during the execution of a program. So similarly to the flowchart that we just created, you can see that we had a variable, we had a count variable, and we stored the value of 0, the data of 0 to it. Okay, we wrote the, what do you say? We wrote the value of 0 to it. Okay, that's basically what variables are. And constant, it's just constant is just a storing of data, storing data that remains constant or doesn't change throughout the execution of the program. So this is normally used for fixed values. Like for instance, if I wanted to make a constant, so for instance, this would look something like constant pi with arrow 3.1415. Now obviously the value of pi can't change, so it would look something like this. Okay, so that's basically what constants are. Okay, normal variable declaration, that looks something like this, right? X is equal to 0, so we use arrows to specify. Okay, so I'm also talking about the syntax of it, so you guys have a quicker version, but we're not going to go in depth on how that works. Let me just pull up the syllabus as well on the site, so it's so I don't mess up something and make you guys confused. So okay, all right, so okay, now the next thing is data types. Okay, data types. So in pseudocode we have 5 data types. These are integer, which is like 3, 4, 5. All right, fixed whole number values. You have real, which is something like 3.14, 9.45, which are basically values with decimals, which go into decimals. You have char, which is something like a, right? You have string, which is something like Ateeb, right? So I'll just double quotation, Ateeb. Then you have boolean, which is something like true or false. Now these data types, they're used when we're declaring a variable. Okay, now in pseudocode is pretty stupid, so you need to specify the data type of the variable. You do this using a declaration statement. The declaration statement looks something like this: declare var name data type, right? That's the way to declare variable. So like for instance, in this flowchart right over here, if I wanted to declare the variable count and I wanted to initialize it, so it would look something like declare count as integer because it's a fixed value, and I would do something like count is equal to 0. That's how we would go about that. Okay, that's how in pseudocode we would go about that. That's how declaration statements work. I'll just make this a bit okay. Alright, so my bad, just a sec. Okay, so that's how declaration statements work. The next thing is inputting and outputting. So in the case of inputting, we just use the input statement. So input var name. So for instance, right over here was input num. So that's literally what it's going to be in pseudocode, input num. So it'll just input the value and it'll place that value into the num variable. Okay, and the other thing is output or print value. So for instance, right over here we used output count. So this would be something like print count. Okay, so that's basically how that would look like. So it's not that complicated. That's just basic inputs and outputs. All right, so besides this, what else do we have? You can also, instead of using print, actually just use output. Okay, just use print output. Don't use print, just use output. Okay, that's according to the syllabus. Just use output. Okay, don't use print. Don't use print. Do not use print, just use output. Just came out of my mouth. Just use output. Don't use print. Okay, so besides this, next you have okay, now you have array declaration. Now we know that array is just a 2D form of representing data, so you can think of array as like a table of sorts. So it would be something like, for instance, if I wanted to declare an array with let's just say with index that goes from 1 2 3 4 5 6, index, right? So let's just say I have an array that looks a bit something like this. Okay, and let's just say that the value at each index is something like a so actually let's just make it numbers. So 3.14, 4.14, 44.4, 90.3, 87.2, and 22.2. So we know that it's we know the length of the array, and we know the data type, which is going to be real. So we would do something like declare array, alright, and then we'd add a colon, declare array name. So let's just say that I want the array name to be, I'll go into a logical example, but let's write the syntax first. So declare array name, array 1 through starting index, length of data type, right? So what this means is, okay, so if we were to declare an array, let's just say that I want to declare an array for this table right over here, and let's say I wanted to call it something like h. Okay, so I'd do something like declare h array. Okay, you don't need to necessarily have array in the name. It could be anything, so you could do like random numbers as well. So let's just do random numbers, and I'd write a colon, and now I know that it's starting at 1. Okay, so if it was starting at 0, we would write 0, but since it's starting at 1, I'll do 1, and then the length of the array is just 6. All right, or you can also think of this as the final index. So 1 through 6 of real. Why real? Because the values are all in reals. That's how you that's how you declare an array. Okay, somebody messaged talking about my accent is crazy, man. If you don't want to listen to my voice, just leave the call. It's literally as simple as that. Nobody's asking you to go study on your own. I literally could not care less about you being here. Okay, so besides that, you have array assignments. So for instance, if I wanted to assign each value right over here, okay, so I would do something like array name, index, and then I do something like value. So let's just say I wanted to go through all of this. Okay, I would do something like random numbers. Index 1 is going to be 3.14, and I do this for every single one of the indexes. So it would be indices. So it would be 6, 5, 4, 3, 2, and 1, right? And then I just do 4.14, 44.4, right? And then there's 90.3, then there's 87.2, and then there's 22.2. Now, one thing that you should know is that you cannot do something like, you can't do something like random numbers is square brackets blah blah blah. You can't do that. Okay, you have to specify each index one by one. Okay, so you can't do something like that. All right, so besides this, okay, then we have conditional statements. Now, the conditional statements, just like this one, we have two types of conditional statements in our syllabus. The first one is an if then else statement, which looks a bit something like this. So if condition, then statement 1, else if condition 2, then statement 2, else else statement 3. What this means, let's just say that I have a variable, and the variable is of type integer. Okay, so let me just write down this example over here as well. So endif, forgot endif. Okay, so let's just write down this example. Okay, so let's say that there's a variable, let's declare this variable as well. So declare x as integer, and let's assign the value of 7 to x. Now let's just say I want a condition, let's just say that I want a conditional statement that sees if x is greater than 7, less than 7, or equal to 7. Okay, so I would do something like, if x is greater than 7, then output x greater than 7. Okay, then I would add a second condition, else if x is less than 7, then output x less than 7. Alright, now the final thing would be an else, and since it's not greater than 7, it's not less than 7, so it's just equal to 7. So I would do else output x is equal to 7. Right, and then I'd end this whole thing off with an end if. That's how an else if, a complex else if then else if statement would look like. Okay, so besides this, okay, so that's how a complex if then else statement would look like. Now, this is not usually used with fixed values, so it would be something like input x, for instance. You can input x, or you can calculate x, whatever, right? All of this stuff. Besides this, the second form is case statements. Okay, so you do case of var name, all right, so the variable name, and then possibility statement, otherwise statement, end case. So what this looks like is, for instance, it's usually used whenever we want to what do you say, case is usually used when we have a set of values that we can match the variable to. So let's say that instead of just okay, let's just say that instead of just checking if the number is greater than 7 or less than 7, I want to see if the number is equal to like 1, 2, 3, 4, 5. Okay, up till 5. So in that case, what I would do is I would do something like okay, I would do case of x, and then I'd write all of these different possibilities. So the first possibility would be something like 1, then 2, then 3, then 4, then 5. Okay, and then there would be the otherwise condition, so we're going to go over this, and then there would be end case. So let's just say that I want to output the values, right? So I would do something like output 1, output 2, output 3, output 4, output 5, right? So 2, 3, 4, 5. All right, so that's going to be that. Otherwise, output no value matched. Okay, so we basically use case of when we we basically use case of when we have a variable and we just want to compare it to different values, okay, and see if it matches those values, and we do whatever we want to do if it matches those values. So okay, so that's basically what case of is. Let me see something and then we'll move on. Okay, alright, so that's basically what case of is. Alright, so basically you can also use this using strings, you can do it using reals, booleans, whatever. Okay, that's basically what case of is. Okay, so besides this, there's a weird ass theory thing All right, so like for instance, if they ask you to use the functionality of an if statement in a case of, this is just to help you guys understand the entire concept, so don't worry if you don't get it, but this is just to understand the entire concept. So we know that in the case of if and if, it's like if condition, then statement, else statement, and if. So condition is basically something that is gonna be boolean. Okay, so for instance, if we were to do this in the format of a case of, what that would look like is case of condition. All right, and we would define condition as a variable. So let's just say that I wanted to or actually I don't think that, actually forget this, this is AS level, my bad, this is AS level. You don't need to know this, this is A levels, AS level. You don't need to know this. My bad, just forget everything I said. I confused IGCSE and AS level. Okay, let's just move on. Alright, so besides that, okay, so besides case of, you have loops. Okay, so loops is to okay, so there's three types of loops. Okay, so the first loop type is a count controlled loop. All right, it basically increments a number over and over and over again. Okay, so this is a for to next loop. Okay, for x is equal to for var name is equal to start to end statement next var name. Right, that's what a count control loop looks like. Okay, in a count control loop, you should know that we know how many iterations are run. So an example of this would be something like for x is 1 to 7, output x next x. Okay, so this would look something like so this would just output 1 2 3 4 5 6 7 and so on. That's what a count control loop is. The second kind of loop is a precondition loop, post condition loop. Okay, let's do post condition loop. Right, now this is a repeat until loop. Okay, repeat statement until condition. So for instance, if we were to create a loop that repeatedly inputs that repeatedly inputs a number and checks to and ends when the number is -1, and it was a post condition loop, it would look something like this. So repeat input num until num is equal to -1. Obviously it's going to be a bit more complicated, but this is just to help us grab context. Okay, so we use repeat until loops when we when we know that statement must run at least once. Okay, that's when we use a post condition loop. The second thing, the last type of loop is a precondition loop. Right, this is the while loop. So while condition statement until condition. Okay, so this is when we use this when when we know that the condition, while and while, why did I write while condition? It would be end while, okay, so this is when we and the condition is the condition is checked before running, right? So an example of this would be while an example of this would be something like input num while num is not equal to -1, do there's also do, so do input num and while. All right, so that's basically what a precondition loop looks like. Now besides this, okay, so let's just recap everything we did and let's move on to basic AS algorithms. So the first thing, data types, right? There's 5 different data types. Declaration, all right, we just use a variable name and then the data type. Inputting and outputting, right? Then you have array declaration, so array starting index, which is basically the value that we start at, and the length is basically the amount of items in the array, right? So in our case this was 6. Then you have array assigning. Remember, you won't what do you say, you won't assign an array like something like array name index is equal to 1 2 3 4. This is incorrect. You would assign each index separately. Then you have the if condition. So a major question that comes is, what is the difference between an if condition and a case of condition, right? You use an if condition, when you have something like you're comparing a specific condition. Okay, so like for instance, you use an if condition when you wanna compare something like x is less than 7, or x is greater than 7, or like for instance x is less than or equal to 4, or x is less than 4 and x is greater than, sorry, and y is greater than 7. Okay, so when there's multiple statements, when there's multiple condition, that's going to be an if statement. Case of is mainly used when you're comparing a variable. So case of essentially is just if x is equal to something, right, and multiple of it. So a case of is just a short way of writing if x is equal to 1, then statement else if x is equal to 2, then statement else if x is equal to 3, then statement else statement, right? So it's just a shorter way of just comparing the variable to its different respective values. That's what case of is. Okay, then you have the count control loop, which basically runs a statement for x amount of times. You mentioned that in the for loop. Then you have the post condition loop, and then the precondition loop. Now all right, so let's talk about the the 5 main types of algorithms that are going to come. Now let me give you guys some tips. Okay, let's go over each one of these. The first kind of algorithm that can come is totaling. Now totaling, in this, basically all we're doing is inputting numbers repeatedly, or inputting numbers repeatedly till a certain condition is met, right? So there's a few kinds of different few kinds of different questions that can come on this. The first time could be something like, for instance, it could be something like input 100 numbers and add them all and output their sum. Alright, so let's think about this logically. The first thing that we're going to do is we're going to initialize a variable called total, and we're going to initialize this to 0. Okay, we're going to initialize this to 0. Okay, now what we're going to do next is we're going to create a count control loop. Why? Because we know the number of iterations. They mentioned it in the question. There's going to be 100. Okay, so what we're going to do now is we're going to we're going to do a for loop for count 1 to 100, and then we're going to I'll also just add the statement to end this. So next count. Okay, now what we're going to do is we're going to input number. Now what we're going to do next is we're going to take the total and we're going to add it with the number. Okay, and then in the end we're just going to output the total. So it's a pretty simple algorithm. We're just initializing a variable and then we're just running an input and a totaling sequence over and over and over and over again. The second kind of thing is something like input numbers till number is equal to -1 and output their sum. So what this would look like is it's going to be the same logic, right? We're going to initialize a total variable and we're going to initialize it to 0. Okay, now what we're going to do next is we're going to repeat. We're going to use a repeat until loop. You can also use a while loop, but it doesn't really make any sense to use that over here. So until, and we're going to come to the condition a while. So repeat input num, right? So we're going to input the num and then we're going to add it to the total value, total plus num, right? Pretty simple step. Now it's said in the question till number is equal to -1, so we're going to do until num is equal to -1. So as soon as num reaches -1, it'll automatically break the loop. It'll cancel it on the spot, right? So, and then in the end we're just gonna output num. You can also do this using a while loop. So what that would look like is you would do total is equal to 0, but remember you would input num beforehand. Then you would do something like while num is not equal to -1, do total is equal to total plus num, input num, end while, output num. Now, a major difference between these two, there's a huge bug in the repeat until one. What that bug is that in the case of a repeat until, if you enter the value of -1, for instance, it's gonna add that to the total sum. So let's just say you entered, let's just say you entered 5, 4, and then -1. What's gonna happen is that the total will become 5, and then you entered 4, then it will become 9, then you entered -1, it will become 8. So in order to combat this entire thing, we use the while loop. Okay, in while's case, if you enter -1, it automatically terminates the loop right then and there. Another way to do this would be to add a condition over here. So you could do something like, if num is not equal to -1, then you would add it to the total, right? So that's how you would go about combating that bug. So remember this, don't make that mistake. Okay, do not make that mistake. That's why you may use while. Okay, you'll just get rid of this condition. Okay, the next thing is counting. Now, counting basically means to keeping account of a certain action. Okay, or if you want like the definition, it would just be the count of times a certain action is performed. Right, so for instance, you could make total equal to 1. You can also make total equal to 1. Yes, you can do that. That's also a smart way to go about it. You can also do the if condition, right? But in my opinion, just use a while loop. Okay, so then you have counting. So let's just say that the question says something like input 100 numbers and count the number of times a number greater than 5 was input, right? So what this would look like is, first of all, we'd initialize a count variable. So count is equal to 0. Okay, we're going to initialize count is equal to 0. Next thing we're going to do is we're going to do a for loop. For x is 1 to 100, because we know the number of iterations, right? So 1 to 100. So next x, right? Next x. Or usually you use i's. I'll also use i's, but yeah. For x, I is equal to 1 to 100. Then we're going to do input num. Now we're going to run a condition to see if num is greater than 5. So if num greater than 5, then count is equal to count. Now this will be +1 since we're counting. Okay, so it's always going to be +1. And if, and so forth. So this will just input 100 numbers. It'll check every single time if that number is greater than 5. If it is, then we're going to then we're going to add it to the thing, and then obviously we're going to add the output statement, output count. Okay, now the second type of question that can come is input 100 numbers. Input numbers repeatedly until -1 is input. Alright, so this would be something like count is equal to 0. Repeat, you would input num. If num greater than 5, then count is equal to count +1. And if until num is equal to -1. So that's what that would look like in a repeat statement. Okay. Then you have a while loop. So in the case of a while loop, you would do something like count is equal to 0. Input num while num is not equal to -1. Do input num. Not input num. If num is greater than 5, then count is gonna be count +1. And if, and then we would input num again, and we would end while. Okay, and then obviously we're gonna output count. Alright, so that's basically what counting looks like. The next thing is maximum, minimum, and average. Okay, so the next thing, maximum, minimum, and average. So maximum, minimum, and average, so we're gonna cover all of these. This basically means to finding the smallest, largest, and average value in a set of data. right? So basically, if I, for instance, input 4, 5, 6, 9, 10, the smallest value in this would be 4 and the largest value would be 10. Okay, so maximum minimum would just be us finding this values. Okay, the average would be just 19 plus 6, so 25 plus 5, so 30 plus 4, 34 over 5, so around I guess 6.9 something, so 6.8 I think. Yeah, 6.8. So 6.8 would be the average of this test data, right? So that's going to be that's basically average. Okay, so let's do each one of these. Okay, so let's say okay, so all right. Okay, so in order to do this, what we do is we first of all initialize variables. So maximum, minimum, and average. Okay, so these will just be initialized to the smallest, largest, and the total. These will just be smallest, largest, and the zero values, right? So maximum, basically, let's just say that we are given a limit of 0 is less than input value is less than 100,000. Okay, so that means that the smallest maximum value could be 0. Okay, so we're just gonna write 0, or let's just make this minus 100,000. Okay, let's just make this minus 100,000. Okay, so the smallest possible value is minus 100,000. Okay, and we're gonna discuss an issue with this later. Okay, we're gonna discuss an issue with this later. The minimum value, the biggest minimum value, could be positive 100,000, and the total is obviously gonna be 0. Okay, so the first thing we do is we're gonna input values repeatedly until, for instance, or actually let's just use a for loop. Okay, so let's just say that input 5 values. Okay, 5 numbers. Okay, so what that would look like is for I 1 2 5, next I, what we're gonna do is we're going to input num. Okay, now the first thing we're gonna do is check if num is greater than maximum. Alright, if num is greater than maximum, then maximum will become num. And if the next thing we're gonna do is if num is less than minimum, then minimum is equal to num. And if. Alright, the last thing that we're gonna do is add it to the total, so total is equal to total plus num. So what exactly just happened? Okay, what exactly just happened? Okay, so all we did is, first of all, we initialized the maximum value to the lowest possible value. Okay, we had which was 100,000, because that's what was mentioned in the question. Just a sec. Alright, so the first thing that we did was assign a value to the maximum. Now, in the case of maximum, we assign the lowest possible value. Why? Because if you think about it, let's just say that you have the values 1, 2, 3, 4, 5. What's the highest lowest value that you could get in this data set? It would be 5. Okay, so essentially maximum should be the lowest possible value. Okay, so just in case I entered something like 1, then it would just be 1. Alright, so it should be the lowest value possible. Okay, so that's why I wrote minus 100,000. Minimum should be the biggest value possible. Okay, so that in our case was 100,000. Okay, the next thing was what do you say? The next thing was assigning total to 0. So if you recall, this is just this concept that we made right over here. So total is just equal to 0. The first thing, and now in the question they said that we need to input 5 numbers, which is why I wrote for I 1 2 5. Now the first thing that we did was input the number. Now there were three things that we needed to do. We needed to count for the minimum, the maximum, and the average. Okay. So right now we're just totaling, minimuming, and maximuming. What the fuck? But yeah, we're just doing that. So we're inputting the number, and then we're gonna check if it's greater than the maximum. Okay, or you can say the highest or whatever. So if it's greater than the maximum, then the maximum would become num. So like for instance, if I input the value 5, now 5 is obviously greater than minus 100,000, so the maximum becomes 5. Okay, now the next thing we're going to do is check to see if num is less than minimum. Okay, so the minimum is 100,000. Okay, so it is less than minimum, so we're just going to do 100, we're just going to make minimum equal to num. Okay, so 5 is less than 100,000, so we're just going to make the minimum equal to 1. Now the last thing that we did was total is equal to total plus num. So all we did in that case was we assigned the value of what do you say, we just incremented we just added num to the total. Now in order to calculate average, we would do something like average is equal to total over 5. Why 5? Because they mentioned in the question that it's going to be 5 numbers. Okay, so total divided by 5, and then we're going to output average. Now you can do this using a repeat loop or a while loop as well. In that case, what that would look like is it would look something similar, except you would let's just say until minus 1 is input, right? So let's just say you would do this using a while loop. So while num is not equal to minus 1, right, you would input num, and while num is not equal to minus 1, you're going to do the same thing again. So first of all, we're going to check if num is greater than maximum. If it is, then maximum becomes num. Alright, and if next we're going to check if num is less than minimum. If it is, then minimum becomes num. And the last thing we're going to do is we're going to add it to the total, and then we're going to input num again. Okay, so input num, and then of course the end while, and the rest remains the same. So it's the same concept, just in a different loop. Okay, it's the same concept, just in a different loop. We missed that. You lagged out. Is my voice still broken? Is my voice still broken? Hold on. Is it? Okay, it's fine now. Are you sure? So, I was explaining. Okay. So I was explaining. Okay. So the entire concept is same. All we did was we used a while condition loop instead, so a precondition loop. Okay, so all we did was check if number is not equal to minus 1. Okay, just like we did before, right? While num is not equal to minus 1, so you'll see that it's just repeated concepts over and over again. So while num is not equal to minus 1, and then if num is greater than maximum, this whole thing is the same, and then we just input the num and while and average the entire thing and just output that average. Okay, so okay, so besides this, the next thing, the problem with this entire thing, alright, let's discuss the problem with this entire thing. Now, a lot of the times you won't know what the minimum or maximum value is. Okay, a lot of the times you won't know what it is. So in that scenario, wait, hold on, / you don't know what minimum or maximum is. So let's just say that I give you like a bunch of numbers, and let's just say that you don't know what the smallest or largest value is. So let's just say that the user inputs something like minus 1 million. In that scenario, it's just going to stay as minus 100,000, right? So in that scenario, what we do is we input the first number and we just make the minimum and maximum equal to that number. Okay, so what that looks like is, for instance, let's say that I input the number x, alright, the number num, for instance. What I'm going to do is I'm going to initialize the maximum and we're going to make that the num, and then we're going to do the minimum and we're going to make that the num. and the rest is just gonna remain the exact same. So I'll just copy paste this one here. So now okay, so num. All right, so the reason that we did this, okay, and then we're gonna do this to 6. Okay, remember, now I'll go over what I just did. Okay, I'll go over what I just did. In this case, in this scenario, what we did is, all we did was inputting the number. Okay, so let's just assume that I input the number 5. So now the maximum is going to be 5 and the minimum is going to be 5 and the total is going to be 5. Okay, now if I input another number, let's just say I input the number 4, and it goes through the conditions. Okay, so instead of here, I input the number 4 right over here. So it checks to see if 4 is greater than 5. It is not, so it's going to skip this condition. Now it's going to check to see if 4 is less than minimum. It is less than 5, so minimum becomes 4. And then it's going to add that to the total, which becomes 9, right? And then 9 over 6, that's just going to be 1.5, and then the output will be 1.5. So essentially what you're doing is, if you don't know what the limits are, if you don't know what the smallest possible value or the biggest possible value is, then that's going to be that's just going to be what do you say, the number. You just input a number and then you just assign that to the maximum and the minimum value. Okay, it's as simple as that if you don't know the limits. Okay, if they say in the question the smallest possible value is like minus 100,000, the biggest possible value is 100,000, or anything for that matter, if they say something like the smallest possible value is all numbers are positive and less than 100,000, then you would know that the smallest possible value is 0 and the largest possible value is 100,000. Okay, but if they don't mention anything like that, then you would follow this approach in which you input a number and you just assign the maximum and minimum value and the total value to that number. Now some of you may ask, why did I make this 6 instead of 5, even though there's 5 iterations? Remember, there's the 5 times that we're inputting number, and then there's a 1 time that we input number beforehand. So if this was 1 2 4, then this would become 5, right? So if this was 1 2 4, then this would become 5. Okay, so you need to count the original attempt as well. Now in the case of this repeat while loop, it would look something like sorry, one more thing. When you're doing until -1, you would also have a count thing. Alright, so the counting would be 0. Okay, the counting would be 0, and you would increment the count. Alright, count, and then you would divide this by count. Okay, so the reason that we did this is because we don't know how many values were input, so we're counting the number of values. So it's just a combination of totaling it's just a combination of totaling, counting, maximizing, and minimum the fuck. It's just a combination of all 4 concepts. Okay, so for instance, if we wanted to do the same logic over here, that would look something like okay, so you don't know what the minimum or maximum is, and until -1. So what we're gonna do, all we're gonna do is we're going to input the number, we're gonna assign the maximum as that number, we're gonna assign the minimum as that number, we're gonna assign the total as that number, and we're gonna start the count as 1. Okay, that's the only thing we're gonna do. So we're just gonna ask for a value. We're just going to ask for a value before we're running the loop. Okay, so that's what totaling, minimum, maximum we're going to do. So before we move on to the array related algorithms, any questions whatsoever? I know it's a lot to take in, so if there's any question, let me know. Can you repeat array, please? We're going to go over array in a while. We're going to go over array after this. Don't worry, we haven't started array yet. Okay, we haven't started yet. Any question? Okay. If I forgot a step, this is why I suggest that you write using pencil. If you think that what do you say? Okay. If you think that you have enough time, write code using pencil and then just erase what you wrote with pencil and just replace it with pen. Okay. Worst case scenario, you write with pen and you just cut the entire thing and you just ask for extra sheets. Okay. You can also try to write the code at the back of the paper on a blank page, right? And you can use a rough sheet. Okay. So you can do all of this. Okay. Alright, so if do you have a PDF? There's a recording from yesterday. It's like 15 minutes. We covered SQL. Okay, so it took me around 35 minutes to do the 15 markers. Should I do it in pencil first or just do it in pen? Man, it really depends on how fast your speed is. Okay, if you think you can cover it. I first did the 15 marker at the back of the page, so on the blank page, and then I just copied it over so that I didn't have time to erase. So you can do it either way. Okay, so then we have is there a difference in the output? One sec. Is there a difference in the output for the program if we use an else if instead of if? I heard it was wrong. If you use an else if, then you're accounting for an additional condition. I'm unsure what you asked me. I'm unsure if you asked. Wait, I can't hand it in with pencil. You can't. You should not hand it in with pencil. It's written right on the front page. Use a pencil. Okay, a blue or black. Sorry, use a pen. A blue or black pen. All right. So let's talk a bit about arrays now. Okay, so let's talk a bit about arrays. Now, in the case of an array, we have something like, you can think of an array as a sort of what do you say? You can think as an array as a sort of index value register. Okay, index value register. So in arrays we have indices 1 2 3 4 5 6 7 8 9 10. These are always in sequence, and then we have random values, so 10 20 4 500 400 60 minus 7 minus 2 0 2 6 and 1 10,000. Okay, now one concept that I need you guys to understand before we go into linear searching and bubble sort is called flagging. Flagging basically means to initialize a boolean variable and we make it as false. Okay, and then we just use a condition like while not flag. We run a bunch of statements and then we end while. Okay, this is what we call flagging. Okay, so I think personally that flagging is the hint to every solution. You'll see why. Okay, you'll see why in a while. So flagging is just like a way to like run loops, and then you just alright, so flagging is just a way to run the loops, and then you just what do you say, you just assign the flag a value. We'll go over it. It's like, for instance, if I were to run a loop until value is equal to 3, I could do that as something like, I could do input num while num is not equal to 3, input num again, right? So that's the first way I could do this. Or if I wanted to use flag looping, I would do something like flag is equal to false while not flag, input num, if num is equal to 3, then flag is equal to true, and if, and while. So essentially you might be thinking, hey Ateeb, this is what do you say, this is way longer, why should we use this? Now in this example obviously it doesn't look that good, but flag looping is just a way for us to understand code better, to write it better. Okay, it's a way to express code better. Okay, so that's why we use flag looping. Okay, so so now the two types of things that we have, I'll just copy this, I'll paste it over here. Okay, so flag looping, if you're confused, use flag looping. I'll show you guys while solving past paper as well. Okay, but basically if you're ever confused, the solution is always flag looping. Okay, I'll explain to you guys in a while. So in the case of an array, we know that we can declare array as an array with starting limit. So in this case we're gonna just declare this array real quick. So let's say that we want to call it values, and then we're gonna write a colon array 1 through 10 of integer. Right, so of integer. So that's gonna be the declaration. Okay, so all right, so the first thing that we do is something that we refer to as linear search. Hold on. Okay, let me just. What the hell? Okay, I can't believe this. Okay, so the first thing is linear search. Linear search basically means to search for an element in the array and find the index of that element. Okay, now what we do is, okay, so like I said guys, flag looping is your way out. Okay, so what we're gonna do is isn't arrays chapter 8, arrays is chapter 8, however I'm just going over the chapter 7 algorithms, which include bubble sort and linear search. Okay, so don't worry about it. So in the case of a linear search, we're just searching for an item in this huge ass array. So like I said, flag looping is where it comes into play now, and a way to do this would be something like repeat. It would be a very weird and complex code. Instead, what we do is we're gonna define a flag, okay? A flag, and we're gonna define this flag as false, okay? We're just gonna write that this flag is false. And then we're gonna run a loop. While not flag, what do you say? While not flag, do end while, okay? So while not flag, do end while. Now, since we're searching for an index, it's a nice idea to initialize index as -1. Okay, now okay, so it's a nice idea to interact. So why did we do it as -1? Because there is no -1 index in an array ever. Indices can't go into the negatives. Okay, so that's why we wrote it as -1. Okay, you can do -2, -3, -4, whatever. You can do any of those, but yeah, that's why we did index is equal to -1. Now what we're gonna do is we're going to what do you say? We're going to go through each one of these indexes. Now if you're using something like while loop, that's going to be incredibly inefficient. So let's just write using a while loop first, so that we also understand the concept of counting and so on. So we know that there's going to be, it says, yeah, sorry. So we know there's going to be 15 elements, so I'm just going to initialize the count variable as well. You're going to see why in a while. All right, so count is equal to 0. Now what we're going to do is we're going to use efficient coding. What efficient coding is, if you're dealing with variables, it's a nice idea to assign those variables beforehand. So for instance, instead of comparing values at count every single time, you can just assign a current value as the values and the count. So now all I have to do is just compare this name. Okay, so it's a nice idea to do something like this. Okay, it doesn't see, you can do it either way, it's not wrong, but it's just a bit more better looking if you do it this way. All right, so like I said, we're going to compare each value. Okay, so we're going to see if the current value is equal to the value of the array. So for instance, let's just say that we're searching for let's just say that the search parameter is equal to, let's just say I want to search for the index called 2. Okay, so it's right over here. So let's say that the current value is equal to values count. Okay, so it's gonna go into each one of these. And why is it gonna go into each one of these? Because I'm gonna increment to the counter. So I'm gonna go like count is equal to count plus 1. Okay, so it's gonna go to each one of these, and it's gonna assign each one of these values to the current value index. Now what I'm gonna do is I'm going to compare the current value and the search. Okay, so I'm going to be like, if current value is equal to search, then we're going to make the index count. Okay, we'll get into this in a while as well. And if, so if for instance it goes over to 20, all right, let's say it starts at 1, right? It starts at 1. Now the value is 10, so 10 gets stored into the current value thing. So if 10 is equal to 2, it's not equal to 2, so this is skipped and it moves on to the next one, and then the next one, and the next one. Eventually it reaches 7, so 0 gets stored over here. It compares 0 and 2, it's not true, so it becomes 8. Now the current value would be 2, and 2 is equal to 2, so it just makes the index 8, because count at that moment is 8. Okay, so right, so that's basically that's the first way to search for an item. Then you output the position, so you would do something like if flag, then output found at, and what do you say, found at, or actually a comma, found at position, and then you would do something like index, else output not found. Now this code is correct, it's just not very efficient. Okay, it's just not very efficient. Now you may be asking, there's a way to make this better. Now essentially, if you think deeper, you'll realize that all it is all the only thing that the flag does is check to see if the if the current value is sorry, we forgot to implement the flag. We forgot to implement the flag. So we're gonna just make we're just gonna make flag equal to true, while not flag or count is count is and count is less than equal to 10. Okay, just a sec, let me just verify. While not flag and count is less than equal to 10, so when it reaches 11 0. Okay, sorry about that. So the flag we basically check to see if it found the variable. So the reason that I wrote this thing right over here is that there's two possibilities that the loop will end. Okay, the first possibility is that flag becomes true, right? So if it becomes true, then this whole thing will become false and then the loop will end. The second possibility is that we run out of indices to search. So it reaches the 10th index and then we increment it by 1 and then it reaches the 11th index. So basically in that case it just goes out of bounds. Okay, so there's two possibilities when the loop will end, and that's basically that. Okay, so if flag, then outfound at position blah blah blah, and so on and so forth. Now another way to go about this would have been to just completely remove flag and then just write this condition itself, but that's a bit more complex method. You don't need to know that. This code right over here is correct. Why would the flag become true? Because we're just using the flag to signify if we found the value or not. We're just using the flag to signify, to check, to keep track of if we found the value in the array. And what are we looking for? The search value. In linear search, you're finding a value inside of an array. Okay, inside of a 1D array or a 2D array, whatever. So that's basically okay. Okay, so that's basically that. The next thing that you have is okay, just a sec, guys. Okay, so that's basically linear search. Another thing that you can do is to use a for loop. Now a for loop obviously is the better way to go about this, I would say, as well. If they don't limit you, go with a for loop. And why do I say for loop? I say for loop because you know that there's 10 indices, right? So in the case of a for loop, it would look something like this. So you would have the flag as false and you would have the index as -1. Now you would just completely get rid of the entire counting thing and you just write for I is equal to 1 to 10 because there's 10 indices next I, right? So there's 10 indices, and then you would just compare each value. So current value is equal to values count, and the rest is basically the same. If current value, just don't increment, right? So and then this is also the same. So it's the exact same thing, right? So except it's a bit smaller code. Okay, so yeah, that's okay. That is basically what linear search is. It's searching for a value in a list of values, okay, or an array. Any questions from linear search? Any questions from linear search? Okay, can you do it with repeat loop? Okay. In the case of a repeat loop, what that would look like is you would have the same thing, right? So let's just assume that search is already defined, so I'll just make this globally defined. Okay, so you would have flag is equal to false, you would have index is equal to -1, you would have count is equal to 0. The only thing that you do differently is you would you would just initialize count as 1, and you would repeat current value is equal to values count. If current value, this is going to be the exact same thing, right? So until flag or count is greater than 10, right? That's going to be what it looks like in repeat. So why did we start it at 1? Because the starting index is going to be 1. If the starting index was 0, then we'd start at 0, but since it's 1, we're just going to start at 1, and then the rest of the output thing would be the exact same. That's how you do it in a repeat statement. Okay. Alright, so can you replace the flag with like position, make it 0, and then you can do that as well if you wanted to remove the flag. Okay, that's actually what I was talking about before. If you wanted to remove the flag, like for instance, let's just take this for loop one. If you wanted to completely get rid of the flag, you can just make it equal to false, and you can just completely get rid of the flag, right? Now in the end, if you want to check, all you can do is you can check if index is equal to -1. So if it's it's not equal to -1, right? So if it's not equal to -1, then that means that it's equal to something else, which means that it's which means that it was found, right? But if it is equal to -1, then it's not found. So you can just get rid of the flag entirely. I just use a flag because it makes the code simpler. Okay, so yeah. All right. So any question regarding flag looping? Alright. Sorry, flag looping, Kara. I mean, like, okay. Alright, so that is basically what that is. I'll just indent this a bit, and then we're gonna move on to bubble sort. Let me just, okay. Indent global. Okay, so that's basically what linear search is. Now, in the case, the next thing that you have is called okay, let me just okay. Damn, okay. All right, so the next thing that you have is called bubble sort. Bubble sort basically means that okay, bubble sort basically means that you're comparing the next value in an array to the previous value, and you're basically just swapping them. Okay, so the bubble sort, if you think about bubble sort real quick, you're just gonna loop through an array repeatedly until it's sorted. Like for instance, in this array, it will be sorted when it's like -2, 0, 2, 6, then 10, 20, 60, 400, 500, and eventually 10,000, right? So bubble sort basically means that what do you say? Okay, so bubble sort basically means that you're comparing the next index with the previous index. Okay, the values. So for instance, let's talk about bubble sort a bit. So in theory, let's discuss the concept behind bubble sort first. So bubble sort utilizes a context we call swapping. Okay, what that means is that assume that you have two values. Okay, so value 1 is equal to 1. All right, actually make this 3. Value 2 is equal to 4. Okay, or actually let's make this equal to 2. Okay, the concept behind the bubble sort is using temporary values. Okay, so you're basically going to be comparing these two values, and you're going to be swapping them. So you're going to compare if value 2 is less than value 1, that means that it's in descending order, so we're going to need to make it in ascending order. Then what we're going to do is we're going to what do you say, we're going to add a temp variable. We're going to store value 2 to that temp variable. Then we're going to make value 2 equal to value 1, and we're going to make value 1 equal to temp. And so essentially what this does is if we have so obviously it's impossible to make value it's impossible to do this without a temp variable, because if you think about it, if you have something like value 2 is equal to value 1, then value 2's value changes, so that's why we use a temp variable. Okay, so this is the concept behind bubble sort. Bubble sort takes this concept and it just makes it bigger. How does it do that? Let's talk about it. So in this case, what it does is instead of value 1 and value 2 being fixed, what it does is that it takes the array random values at index, and then it takes the array values at index plus 1, and then it compares them. Okay, so bubble sort is basically utilizing this concept on a bigger level. Okay, so essentially, all right, so let's talk a bit about bubble sort. So bubble sort, all right, so in bubble sort, the first thing to do is to use a okay, let's do this using a repeat until loop. So what we're gonna do is we're going to repeat until. Okay, now if you think about bubble sort, the first thing we're going to do is we're going to know that the maximum value that can be achieved is index total minus 1. Why? Because assume that bubble sort reaches at point 9. Okay, value 1 will be index 9, and then value 2 will be index 10, right? So that's the maximum. If it goes over to 10, however, it's going to reach values index 10 and then values index 11. Okay, so that doesn't exist. So we're going to repeat until until current index is greater than 10. That's the first condition. The second condition is going to be the swapping, okay, or the flag looping. You can call it a flag as well. So like I said, we're going to declare a flag, okay, and we're going to set it as false. Now you can essentially think of this flag as if array is sorted. In bubble sort, the normal way that you memorize bubble sort, it basically looks they basically name flag as swap, so it's essentially the same thing. I just like to write it as flag. All right, now until, and we can also write over here until flag is equal to false. So if until array gets sorted, or the array goes out of limit, so until current index is greater than 9, actually, because it's going to be total minus 1. Okay, so it's going to be total values minus 1, so it's going to be current index is greater than 9. Okay, so because if you reach 10, then that's going to go into out of bound limit. So now that we have a flag and we have a repeat loop, what we're going to do is we're going to run a for loop. We're going to run a for loop inside of this. The for loop, it will look something like so it will look something like for I first index, which is just 1, to last index, which is 10. Okay, so for last index 10 minus 1, because again we use last minus 1, because if it reaches 10, then it's gonna go out of bounds. Okay, so it's gonna go out of bounds. So I'll just rewrite this as 9. Okay, for I 1 to 9, next I. All right, so for I 1 to 9. Now remember, I told you guys all we're doing is we're gonna compare the logic. Okay, so I'll just copy paste this entire thing and I can just put it over here. Okay, so what we did is we basically, first of all, we stored the current value at the current index in value 1, and then we stored the value at the next index in value 2. So like for instance, let's just say we're at index number 1. Okay, let's just say I is equal to 1. So value 1 is going to be 10, value 2 is going to be 20. Okay, so this is going to be 10 and this is going to be 20. All right, now it's going to compare these two. If value 2 is less than 1, then it's going to swap these values. Okay, so but since it isn't less than 1, it's going to skip. Let's take example for the 6th one. Okay, so let's just say that I is equal to 6. Okay, let's just assume I is equal to 6. Okay, now what we're gonna do is okay, so since we're okay, I think my okay, my bad. Hold on just a sec. Alright, is okay. Alright, so is my screen visible now? Alright, so okay, so what point was the last where it was visible? What point did it like stop being visible from? What point did it stop being visible from? What was the last thing that you guys saw? Oh shit. Okay. Okay. No worries. No worries. All right. So like I said, what we're gonna do is we're going to loop from 1 through 9. Okay. So we're just gonna go from each one of these index. Now, why 9? Why did we do 9? Because again, if we reach 10, then it's gonna go out of bounds. Okay, it's gonna go out of bounds. So we're gonna go through 1 and 9. Now, if you remember, 5 minutes ago, I told you guys that bubble sort essentially uses this concept right over here, just on a larger scale. So I'll just copy paste this right over here, and practically our entire code is already done. Why? Let's just assume that I is equal to 1. Now, when I is equal to 1, this is going to be 10 because the value at first index is 10, and this is going to be 20 because the next index is 20. Now it's going to compare these two values, and since it's already in order, it's going to skip. Okay, so let's take another example. Let's take an example where it's not in order. Okay, let's take an example if it's not in order. Okay, so okay, let's take I as 6. Okay, because -2 and 0, these are not sorted. Okay, let's take I as 6. So when I is equal to 6, okay, so this value 1 will be -2, and value 2 will be 0. Now, this is sorted as well. Actually, let's take a different example. Let's take I is equal to 5. Okay, so when I is equal to 5, this is going to be 6. Oh my god. Okay, when I is equal to 5, this is going to be 60, and this is going to be -2. Okay, all right. So okay, so this is gonna be -2. Just a sec, guys. Okay. Okay. So this is gonna be -2. Sorry, why do I have index? You're right. It's not gonna be index. It's gonna be I. That's my bad. I just wrote index, so I'll just change this to index. Okay. So there's some small syntax errors you may see, but yeah, this is index. All right. So this is gonna be -2. Now it's gonna compare these two values. So value 2, which is -2, and value 1, which is 60. So -2 is less than 60. So what it's gonna do is it's gonna take a temp variable, and it's gonna store -2 in the temp variable. Then value 2 will become 60 because we're basically taking this value and storing into value 2, and then value 1 will become the temp value, which is -2. So essentially we just ended up swapping this. Okay, so yeah, that's basically the entire concept behind this, and this is almost everything done. The last thing that we need to do is to account for what do you say? The last thing we need to do is to account for the flag. Now, I told you guys the flag specifies if an array is sorted. Okay, the flag specifies if an array is sorted. So at the start we're going to assume that the array is sorted. Okay, so we're just going to assume that the array is sorted. Now, every time that there is a swap, that obviously means that the array is not swapped, right? Is not sorted. So all we're going to do is we're going to add a flag is equal to false over here. So if it sorts through the entire array, and then it and then it realizes that there was not one difference, then that means that it is swapped, and that would mean that bubble sort is complete. Okay, so this is basically all of it. One last thing, we're just going to okay, yeah, no, this is it. Okay, I think yeah, now this is obviously a bit okay, this is the inefficient algorithm. An efficient algorithm would use last and first. Okay, so an efficient algorithm would use last and first. So it's going to be similar, except in this one what we're going to do is we're going to define start as 1, and we're going to define last as 10. And all we're going to do is we're going to do index from start to last -1, and then we're going to change this 9 to last -1, and then we're going to just do last is equal to last -1. Now, why do we do this? I'll explain. Okay, why do we do this? Well, the reason behind this is that all we're doing is after each value is checked, okay, all it does is that it decreases the length of the array. Okay, it just decreases the length of the array. So for instance, let's just say that there is an 11th and 12th index over here. Okay, so let's just assume this is 5 and this is like 2. When it's going through the first loop, it's gonna compare all of these indexes and it's gonna sort out all of them. Then it only needs to sort out this part of them. Then it only needs to sort out this part of them, and then it only needs to sort out this part of them, because because at the final index it's already going to be sorted. Okay, it's already gonna be sorted. So that's basically why we use this, and this is a much more efficient algorithm. Okay, we call this the efficient algorithm. And I think the code is correct. Sorry, or in this case, what we're gonna do is or last is equal to one. What last is equal to one means is that it reached the final index. So yeah, so we're just making last is equal to one. And with that, I think we can close this algorithms chapter. So is there any question from the bubble sort? Any question from bubble sort? We're gonna go over 2D arrays in chapter 8. Don't worry. Any question in regards to bubble sort? How can we tell if it's asking for ascending or descending? You're gonna look at the question. Essentially, the only difference is gonna be you change this equal to less than sign to a greater than sign. Okay, so you're gonna see in the question. The question's gonna specify. Normally, it's in ascending order. Normally. Can you explain the temp thing again? Yeah, of course. So imagine that you have a value that is equal to 3, and then you have another value which is equal to 2. Let's say that you want to swap these values. What you do is that you take a variable, we call it the temp variable, and you assign one of the two values to them. So for instance, I can assign value 2 to it. Now what you do is that you basically make value 2 value 1. So basically you're making this 2 into a 3. So you do value 2 is equal to value 1. Now the last thing that you're going to do is at this point value 2 is going to be 3. Right now all you need to do is put 2 over here. So you do that by taking it out of the temp, and you do value 1 is equal to temp, and you basically swap the variables. Can you move a bit and zoom out with the temp thing? You can get these notes after the recording. Don't worry, I'll send these notes. I don't know where you want me to scroll to, but you'll get these notes afterwards. So don't worry about that. And with that, I think we can take a 5-minute break before we proceed on to the theory part. So yeah, we can take a 5-minute breather, guys. Take a 5-minute breather. For your first technique, you didn't increase the index. For my first technique, I didn't increase the index because wait, what? I did. I did increase the index. Wait, no, this is linear search. You don't need this condition right over here. You're right. You don't need that. Since we're not dealing with indices at all, you just need the flag condition. You're right. You don't need to delete that. Okay. Okay. So right. Let's take a 5-minute break. And so far we've covered the entire of chapter 9, chapter 10, and we've covered flowcharts, structure diagrams, program development lifecycle, pseudocode, and basic pseudocode algorithms. Normally, the questions on these they're like I think 5, 6, 7 marks. So the learning these 6, 7 algorithms, it's really important. It's gonna be the easiest marks ever. Okay, so yeah, learn these algorithms. Okay, so yeah, let's take a 5-minute break, and we'll be back at exactly 18:06. All right, let's move on. Okay. So, uh, all right. Okay. So let's talk a bit about test data. Now, when we talk about test data is essentially some test values, you can say, that you plug into a function, a procedure, a statement, any kind of code. Okay. So there's just test values. Okay. So you can say that they're input values used to evaluate evaluate the functionality of a code base. You can shorten it down to that. It helps identify errors, right? So that's basically what test data is. Now there's four kinds of test data in our syllabus. This test data is okay. So the first test data is normal data. Now this data is within range or slash accepted data slash supposed to be accepted by the code base. So for instance, if you have a code base that inputs a value from 1 through 10, normal data would be something like 7, okay, or 5, okay. Then you have what do you say? It's in an acceptable range, okay. So the next thing that you have is abnormal data, right? Abnormal data is rejected by the solution, okay. So not within range, rejected data, or you can say something like erroneous, which basically means that it's filled with errors, or it should cause errors in the data, right? So for instance, an example of this would again be like if you have a number, if you have a code base that takes in whole numbers, or a program that takes in whole numbers, what do you say? Then you would okay, if you have a program that takes in whole numbers, you would input something like minus 1.14, which is a real. Okay. Okay. Then you have okay. Besides this, you have extreme data, which is for instance, these are the largest and smallest values that are taken. Okay. So for instance, the values at range or largest and smallest value, right? So for instance, if we have a range of 0 to 100, I'll just define a global range as well. So range, let's just define a range as 1 to 100, right? So let's just say normal data would be something like 50, abnormal data would be something like 1.2, or yeah, 1.2, or maybe 300. Extreme data would be 0 or 100, sorry, 1 or 100, right? Extreme data is two values that are accepted, okay. They're accepted, okay. They're accepted. Boundary data are a set of two values which are, what do you say, which are at the edge or at the boundary, with one being accepted and one being rejected. So an example of this would be 100 and 101. So you could say that the 100 value should be accepted and 101 should be rejected. Or an example of 1 and 0. So 1 would be accepted and 0 would be that. Now, okay, these are the four types of test data. Now, the difference between extreme data and boundary data is that extreme data is basically value at the boundary of the data, or the edge of the data. It's still accepted, whereas boundary data will include one rejected value and one accepted value. The next thing that you have is called a trace table. Now we're gonna do trace tables when we do past papers, so we're not gonna go much into it. Let's just go over the definitions. So a trace table is used to utilize the documentation of every step in an algorithm. So for instance, we have an algorithm that inputs a bunch of numbers, inputs and then calculates whatever, and so on and so forth. All of this you will trace using a trace table. So it's used to basically see and test the functionality of an object. Now a dry run is a manual process of running each line of code, each step of algorithm, one by one. So if you have a large code base, you go line by line by line by line by line by line, and so on and so forth. That's called dry running. Now, okay, let's do this. Okay, now a thing that you should know is how to write an algorithm. Okay, there's a few things that you should know about writing algorithms. Okay, so let's talk about them. Okay, so how to write an algorithm. Okay, so how do you write an algorithm? So in this scenario, in the case of writing an algorithm, the first thing you need to make sure of is make sure problem is understood. Okay, so you want to make sure that the problem is understood, it's directed in the algorithm, and so on and so forth. Now the second thing is to break down the problem into sub problems. Okay, so if you remember, I made this like I made these questions and I broke them down into sub parts. Okay, so that's basically what this is, decomposition, right? So breaking down the problem into sub problems. Okay, now the third thing is to identify data and its data type. So for instance, the variables and the respective data types, all of this, identifying that. Okay, the next step is to decide construction method. Right, so this could be either pseudocode, flowchart, or a programming language, whatever. Right, so that's the fourth step. Now the fifth step is to construct it, and you should make sure it's readable by others. And then the last step is to use test data to test your algorithm. Okay, so these are the 6 steps of writing an algorithm. Okay, so besides this, okay, moving on, the last thing is validation and verification. Alright, so validation and verification. So let's talk a bit about both of these. So the validation basically means to check the reasonableness of data before it's entered, before acceptance. Okay, so check the reasonableness of a data before it's accepted by the program. So there's a bunch of different checks that we use as validation. Okay, so these checks are the range check, and we're gonna write pseudocode for each one of these as well. There's a range check, there's a length check, there's the type check, and then there's the presence check, format check, and lastly check digit. Alright, so let's go over each one of these. Now a range check takes an integer value, and what it does is it compares it with a given set of range. So for instance, you would do something like repeat, and then you would do input num, right? And you would you would see if repeat input num, if let's say the range is 0 to 100, right? So if num is less than 0 or num is greater than 100, then output error, and then you would do end if, and then you would add an until num is greater than 0 and num is less than 100. That is basically a range check. You have a different value, you have different sets of values, and you're basically going to check to see if it's what do you say, if it's like in that range. Right, so is boundary accepted or not? Boundary data is a set of values, it's a group of values. One of those values is accepted, one of those values is rejected. So like for instance, in this range check, let's just take this range check as an example. The range in this would be 0 through 100 inclusive, right? So 0 through 100 inclusive. So boundary data would would be something like -1 and 0, right? -1 is going to be rejected, 0 is going to be accepted. Or 100 and 101. 100 will be accepted, 101 will be rejected. Okay, so it's basically going to be the value, an accepted value plus -1. Okay, that's what boundary data is. Then you have length check. Length check basically means to input. I'll just change this to input. Right. So length check basically means to repeat, and you would input num if input string. Okay, input string. If length of string is equal to 8, for instance, is not equal to 8. So let's just say that I want the length of the string to be equal to 8. So if it's not equal to 8, then output error end if until length string is equal to 8. That is basically length check. Length check is used to see if a value is within a given limit. Okay, it can also be within a range. So you can say if length string is less than 4 or length string is greater than 8, and you can say until length string is greater than or equal to 4 and length string is less than or equal to 8. Right, so you can also do it this way. This is another way of doing it. The next thing is type check. Okay. Type check basically means to now there's one kind of type check. There's the div type check. What that is you have repeat input num, right? Okay. Now type check would be to check to see if a whole number, for instance, is a whole number, right? Now when you have a whole number, dividing it by itself would give you the remainder of when you have a whole number, dividing it by 1 will give you a remainder of of 0. What does that mean? Okay, let's look over here. Let's take a long division course real quick. So if you have a whole number, like for instance 84, and you're dividing this by 1, you're gonna get 84 as the quotient, and the remainder would be 0. Okay. However, if you have a whole number, if you have a float number 84.1, for instance, and you're dividing it by 1, then your quotient will be 84 and your remainder will be 0.1, which is not equal to 0. Okay, so in the case of type check, what you're doing is you're getting the remainder of the number divided by 1 and seeing if that is equal to 0. So if div num1, div is used to get the remainder. We'll dive into this in chapter 8 as well. If num1 is not equal to num, right? So div is for quotient, right? So for quotient, this right over here, this is the quotient. Okay, div is for quotient. So if div num comma 1 is not equal to value or not equal to the number, then then output error end if until div num1 is equal to number. So what I'm trying to say is that okay, if you have this, then the quotient will be 84, which is equal to the original value. However, if you have something like this, then it's gonna go into the decimals, which is not equal to the original value. Can't we use round? I'm unsure. I mean, I guess that works as well, but I'm unsure if round gives you a float value like 26.0, so it could be wrong, but might as well just use div. Might as well just use quotients. Okay, I guess you could technically do that, but I'm unsure, so might as well just use quotient rule. Okay, so that's the type check. Presence check basically means to check for spaces. Okay, so repeat input string if string is equal to nothing, then output error, and if until string is not equal to anything, right? Is not equal to an empty space. Now, what do you say? We have to use one equal to sign in pseudocode. Now, the next thing, format check. I have a huge PTSD with this because this came in my exam, and at first I was really confused on what to do, but it's really simple because this was the first time that it came into our exam, right? So it's really simple. Okay, so what you want to do is you want to do a repeat until condition. Okay, and now you're gonna input string. Let's just say that I want that I have a string, okay, and let's just say it's ABCD 1 2 3 4, and the left 4 are always gonna be ABCD. So a format check would be something like input string if substring, we're gonna get into this as well, of string 1 4 is not equal to ABCD, then output error, and if until substring of string 1 4 is equal to ABCD. That's basically that. You can also do this using the right thing. So if it was, for instance, 1 2 3 4 ABCD, then you would do it at 5 to 4 and 5 4, right? So there's a lot of things. Okay, so there's that substring. You can also do it for the middle one, so it basically depends on the substring. We're gonna get into this in the chapter 8. Now check digit is basically check digit is basically a final digit included in a code that's calculated using a calculation algorithm, right? So that's basically what a check digit is. Why 5 4? Because I'm checking for the rightmost, so right 4 are always going to be ABCD. So that's going to be, this is 1 position, 2 position, 3 position, 4 position, 5th position, and then 1 2 3 4. So 5 4. Okay, because there's 4 characters. Because the substring, let me confirm this, substring, yeah, in the substring 5 is basically the starting value and 4 is the length of the values that you need to go for. Okay, so then you have verification. Now verification is going to be the what do you say, where is it? Okay, so verification is making sure data is copied correctly from one place to another / data is verified at the time of data entry. So there's two types of verification. The first type is called the double entry check, which basically means to enter input data twice, compare the data input and see if they're equal. So you'll see an example of this on, like, whenever you're setting up for something like for instance, if you have if you're creating a Google account or a Discord account, it's gonna ask you for your password, right? So it's gonna go something like for instance, password and then new password, so 2 different passwords, then it's gonna compare them. That's double entry check. The next thing is called visual check, which basically means that stop being blind, and this basically means that user views the input data manually, right? And the system displays data on screen after entered and yeah, that's it. That's screen or visual check. Okay, you can also call this screen. Okay, so it's screen slash visual check. It's literally just stop being blind. Okay, so that with that we have the ending of chapter 7, and we can conclude chapter 7 as well. So yeah, is there any specific example? Not really. Double entry is just when you like enter passwords, for instance, and then verification. What do you say? Is there no pseudo for check digit? Now, so far in the exams, no. However, to be honest, they can ask you to create a pseudocode algorithm that calculates a check digit. But if they do that, they're gonna tell you how to calculate that check digit. Okay, so you just have to look out for that. So there's no specific algorithm for pseudocode check digit. Okay, there's no specific one, but they may ask you to write an algorithm to calculate check digit. That would just be like a bunch of combination of like arithmetic operations. So they could say something like the check digit is gonna be so for instance they could say something like check digit is gonna be the length of the string divided by, let's just say, appearances, or let's just say divided by 7. Okay, divided by 8 for instance. So they'd ask you to calculate check digit in terms of pseudocode. So action is going to be length of string over 8. So that's basically what check digit is. Okay, so yeah, there's they can ask you to calculate check digit, but I don't think it's going to get that complex. They haven't done that ever, so I don't know. How to find number is integer. Like I said, you use the quotient rule right over here in format check. No, not format check. In type check, you use the quotient rule. You basically get the quotient and compare it to the original ones. Can you explain type check for other? Uh, I don't think there is any other data checks. I don't think there is any other data checks actually. But data types that there exists. So yeah. There's just a integer and real thing. Besides this, okay, that concludes chapter 7. Okay, so div gets the remainder, mod gets the answer. Div gets the quotient and mod gets the remainder. Okay, div gets the quotient, mod gets the remainder. What does that means not equal to? What the quotient doing? What? Alright, so let's take a 5 minute break and we'll be back in 5 minutes. All right, I'm back. Let us. Okay. All right. So. Okay. All right. So chapter 8 programming, like I said at the start, we're not gonna dive deep into this because you guys wanted to do past papers instead. So we're just gonna go over the theory and discover the basics. Okay. So okay. So the first thing that you want to know about chapter 8 is called programming constructs. All right. This is the theory part of chapter 8. Now this includes data use, which basically means stuff like variables, constants, and arrays, right? Different types of data. Okay. The next thing that you have is okay. The next thing that you have is sequence, which basically is the order in which steps are executed. Right. The third thing that you have is selection, which basically means choosing a path through a program. The next thing that you have is iteration, which is repetition of sequence of steps. And the last thing that you have is operators, which are basically arithmetic or logical. Alright, so there's the different types, or Boolean, okay? So there's 3 types of operators, arithmetic, logical, and Boolean. So there's different data types as well, okay? So you should know what a data type is. Okay, alright, so let's just write this down at chapter 7 actually. So chapter 7, let's just write this down in here, because this is more of it. Where is it? Okay, so a data type in general allows for efficient processing and storage. Okay, so if you define the data type, it's going to be more efficient in the code. Okay, and it allows different data to be stored appropriately. Allows different data to be stored appropriately. And then you have what do you say? And then they allow for proper manipulation. So like arithmetic or string manipulation. So you can see, like, if you assign a data type to a variable, it makes it much easier for you. It makes it more efficient. It allows data to be stored properly, and it's gonna be easier to manipulate the data. So besides this, so that's basically the programming construct, and that's data types. The next thing is input and output. Okay, so let's talk a bit about input output. So IO, input slash output. IO input output, basically programs require input output, right, to process data, right? So you always enter some form of input, or you always output some form of input, and so on and so forth, right? So you should prompt users properly with instructions, right? Besides that, normally inputs are strings, and then you just convert them to integers, and so on and so forth. Then you have but yeah, that is basically it. That's basically the first part, the theory part. The next thing is file handling. Now, in the case of file handling, so basically computer stores data in a file, right? So let me just, there we go. File handling. So computer stores data in a file. Okay. Okay. So now you can say, you can give the example of a RAM, like data in RAM is volatile, so in order to store it permanently, it's stored in secondary storage. So yeah. Now, writing in a file or reading from a file, you have to open the file first. Open file, open file first. And this is done using open file text file name .txt for operation. Just a sec. Alright, so okay, so file handling, open file name for write. Now, in order to, I'll talk about operations in a while, right? So, in the case of writing to a file, what you do is you use the operation write. So, what that looks like is something like open file file.txt for write. Okay, that's what that looks like. Then what you do is you use the write file command, which basically states write file file.txt, and then you put in the value. So you separate it by a comma and then you put in the value that writes to a file. And then of course always close file, which is just going to be close file file name.txt. Okay, so always close file. So then you're going to do what do you say? Then you're going to do close file file.txt. Okay, so that's the three steps to writing a file. In order to read a file, what you do is you do the same thing, right? So operation, except instead of operation write, you do operation read, reading a file. So what you do is you do open file for read, and then you change this to read file. Okay, so read file, and then you basically have the value. Now, whatever line is being read from the file at the time, that line goes and is stored in the value variable. Okay, a line. So, like for instance, we have a file and the first line is like hello world, and you read the file, then it's gonna go ahead and it's gonna store in the value variable. Now, after this, you have reading till EOF. Now, EOF is a method of determining if it's the end of file. So now the normal thing, of course, again, you're gonna open file, right? You're gonna open file file.txt for read. There's nothing different about that. Okay, now in this case what you do is you use a loop. So you say while not EOF file.txt, I'll get into this in a while. While not EOF file.txt, do read file okay, read file file.txt line, then you can process this line right over here. So process line, I'll get over this in a while. End while. Okay, so EOF is basically stands for end of file. Now EOF is going to be like a function, and EOF basically determines if the file is at the end of the point. So how file handling works is that you have a bunch of lines, and then you have a pointer that goes through each one of these lines. Okay, I'll just make it a bit better. So you have lines. Okay, so it looks a bit like this, and and there's a pointer that points. Every time that you read a file, this pointer decrements, so it goes to the next line and then the next line. Okay, eventually it'll reach the final line, and at this point EOF of that file is gonna return true. So that's why we use not EOF. Okay. So what I mean by process line is whatever they ask you in a question. Sometimes they're gonna say that you need to output the first two characters. For instance, they can say something like output the first two characters of the line. So you could say something like output substring line 1 2 or anything for that matter. Okay, so that's basically file handling. You store the value that you read in the line variable and then you just deal with it accordingly. Okay, so yeah, that's basically file handling. Then you have library routines. Library routines. Library routines are basically now they're basically pre-tested. Okay, let's just okay, pre-tested and available for use. Okay, so they allow us to what do you say? They're called the standard library. They're a standard library of functions and procedures. Okay. Besides this, there's like four. I think four. Let me check as well. Uh, okay, mod. Yeah, there's four different library routines. There's mod, there's div, there's round, and then there's random. Now, when we talk about each one of these, they take in a certain parameter. Okay, so they're already defined functions, you can say. So mod basically takes in two parameters, which are going to be the number one and dividend. So this basically returns the remainder of num1 divided by dividend. So for instance, if you have a long division like this one right over here, 10 divided by 3, okay, mod would return so this would become 9 minus 10, so mod would return 1. Okay, then you have div, same thing, num1 dividend. Okay, this returns the quotient of num1 divided by dividend. So this basically would return something like this, right? So that's what that would return. And then you have a okay, then you have round, which basically takes in value and then it takes in decimal place and it rounds value to x decimal point. So for instance, 23.4444 would become 23.4 if the thing is round 23.44444 at one decimal place. So yeah, that's basically round. Then random returns a random value between 1 and 0, or a random float value. Random float value. Now in order to calculate a random digit, what you do is you first of all you calculate a random value. So that would be something like, for instance, if you wanted to calculate a random value, you would first of all do random. This will give you a random float value from 0 to 1, and then you would multiply this value by the maximum, and then you'd add the minimum to this value. Right? Or was it max minus min? Let me just confirm. Hold on a sec. Yeah, it's max minus min. Okay, so it's gonna be random multiplied by max minus min. So this will become introduce a random float value between max and minimum. If you want to calculate a random integer value, you're just gonna round this entire thing. So you're just gonna go round off this and 0 decimal places. That will become what do you say? That will become an integer value. Then you have creating a maintainable program. So there's a few points you should know. Creating a maintainable program. These points include using meaningful identifier names. Then you have divide each module into procedures and functions. Okay, one sec. Divide each module into procedure and functions. Right. Then you have comment on your code. If you guys noticed while I was writing code in chapter 7, you're gonna notice that I was doing a lot of what do you say? A lot of double slash comments. Like for instance, right over here, where is it? Right over here, I use double slash. This basically signifies a comment, and the comment is oh fuck, my bad. What is this weird ass platform, bro? Okay, so what was the last thing that you guys saw? What was the last thing that you guys saw? Random. Okay, so then you have after random, you have creating a maintainable program. So when you're talking about maintaining a maintainable program, you use three things, which is meaningful identifier names. You divide each module into procedure and functions, and you comment on your code. So comments, okay, comments are basically what do you say? Comments are texts in code which are not run. So if you guys notice, I used a bunch of comments when I was writing code in chapter 7. In pseudocode, you specified using double slash, double forward slash, like right over here, and these comments are ignored by the code base. Okay, so then you have okay, then you have a all right. So like I said, string handling. String handling. String handling basically means that okay, so string can store various characters, and we know this already. So then you have okay, so in our syllabus we have different methods of string handling. The first one is called the length. Okay, the length. What the length function does is okay. Let me just bring out the syllabus again. Length. Okay, just a sec. Okay, so the length function, it returns length of string. This returns the amount of characters in a string. Okay, so the amount of characters, the language, and so on and so forth. Then you have uCase of string, which returns the string in uppercase. Then you have lcase of string, which returns the string in lowercase. And then you have okay, let me just string in lowercase. And then you have substring, string start length, which basically means returns the part of string starting at position start for len characters. E.g., for instance, you would have substring of Ateeb with start of 2 and 3 would return TEE. Okay, so it's gonna be what do I say? It's gonna be inclusive. Okay, it's gonna be inclusive. That's gonna be string handling. After string handling, we have Okay, arithmetic, logical, and Boolean operators. So arithmetic arithmetic operators, these include stuff like plus, minus, divide, multiply. Okay, then you have logical operators, which include stuff like equal to, greater than, less than, greater than, equal to, less than, equal to, not equal to. And then you have Boolean operators, which basically include not, and, or. Okay, so these are Boolean operators. Then you have nested statements. So nested nested statements. The nested statements mean code statements can be placed inside one another. Uh, Now they help reduce data duplication, and yeah, that's basically it. Then you have functions and procedures. Now, functions and procedures, they're basically, what do you say? A procedure is basically a collection of programming statements. Okay, so procedure. Let's talk about procedures first, actually. So let's just remove procedures. It's a collection of programming statements without any return value uh, that accomplish a particular task. So in the case of procedures, how that looks like is, okay, so in order to create a procedure, that looks something like procedure, name, parameter, data type. Alright, and then you do end statements, and then you do end procedure. So an example procedure could look something like, for instance, procedure X, or procedure say hello, n times, right? So n times. So times is gonna be an integer. So we can say something like, okay, it ended up again. Okay, it ended up deleting. Okay, great, amazing, amazing, amazing. Okay, let me just plug in my MacBook. So I think that's why. Yeah. Okay. Okay. Alright, so that's gonna be okay. There we go. Alright, so procedure, say hello n times. So let's just say that this is a procedure that is supposed to say the word hello, the amount of times that it's being entered. So we're just gonna create a for loop for I 1 2 times, output hello, next I, end procedure. Okay, that's gonna be that. Then you have calling that procedure, which is going to be call say hello n times, and then you just enter the value. So something like, for instance, 5. This will call it 5 with the times 5 times. So hello will basically be output 5 times. Uh, just 5 minutes. I'll be back. I need to go do something real quick. Alright, I'm back. Okay, for those of you wondering where I was going, okay, I have a math exam tomorrow. My friends are just DMing me questions, so I was just solving it for them. Okay, so procedure is that. Okay, so in the case of functions, okay, in the case of procedures and functions, right? So this is a procedure, so I'll just bold that as well, procedure. All right, so in the case of functions, we have okay, so in this it's a collection of programming statements that return a calculated value, a value that is calculated via accomplishing a particular task. Okay, so you do a task and you get the what do you say? You get a value that is returned in a function. So for either one of these, you have a header. Okay, so a header, which is basically the first line. All right. Now, in the case of a function, you can say it's something like function name param data type. Now, remember there can be multiple parameters as well. Then you add a colon, returns data type, statements, and function. All right. So an example function would look like function calc sum, and you do num1 is equal to integer, num2 is equal to integer, returns integer, and you would do value is equal to num1 plus num2, return value, and function. And to call a function, you do something like val is equal to calc sum of 1 and 2. That's basically how functions work. Okay, so then you okay, so after functions okay, so after functions you have okay, you have local and global variables. Okay, local and global variables. Now, in the case of a local, any part, okay, so any part of a program that can use a global variable. Okay, so for instance, if you have a really large code base and you have a global variable, you can use that variable in any function, procedure, statement, whatever. Okay, a local variable can only be used in the scope it's declared in. So for instance, if we just take this function, for instance, this value right over here, it's a local variable. However, if I were to create a different variable, like a completely unrelated variable like j is equal to 1, this would be a global variable since it's in the whole program. Okay, now what do you say, if you have a declaration inside of the function or inside of a procedure and you want to make it global, then you would do something like declare value data type what do you say, as global. Okay, so you don't need to necessarily write as global. Okay, so you don't need to worry about writing as global to normal statements. Do not write as global to normal statements. You must only do this if you want to convert a local to a global. Okay, then lastly you have arrays. So we talked about one-dimensional arrays. Let's talk about two-dimensional arrays. Okay, so arrays. Now, in the case of an array, you can plug in any value of x. It can be 1, it can be 2, it can be 1 over 2, any value of x. But the reason I did 1 was because 2x minus 1 is equal to 2x minus 1 के अंदर अगर हम लोग 1 plug in करें so this is going to give us the simplest answer. We would have plugged in any number, but plugging in 1 was the simplest way to go about that, so that's why I plugged in 1. Alright, so yeah, So arrays. So we talked about one-dimensional arrays. Let's talk about two-dimensional arrays. So an array is a data structure, a data structure. All right. In this, it containing several items of the same data type. Now, in the case of what do you say? In the case of an array, we have a two-dimensional array. Okay. Now, a two-dimensional array is a bit more complicated. You can think of it as an array of arrays. Okay, so you can think of it like a big array. So there's like this big array, and then there's smaller arrays in that array. So it looks kind of like this. Okay, so if you think about it, it's really not that complicated than most people make it out to be. So you don't have to worry about it like that, but it's just an array of array, a 2D array. Okay, so in this case scenario, declaring a 2D array, declaring a 2D array would look something like what do you say? Declare array, right? And you would go declare name array 1 through start index length. All right, so start index length. All right, we also refer to this as like the row lower and row upper. So let's just do that: row start, row end, and comma, column start, column end. So you can memorize it in any. You can memorize it as rows and columns. You can memorize it as arrays inside of an array, and of course of data type. So an example declaration for this one, for instance, so this array right over here, if we make this into a table, it would look something like this. Okay, so let's just make this into a table real quick. It would look something like okay, so value, and let me just add another value. So it would look something like 1 1 1 2 2 2 2. Okay, stop screaming. Oh my god. Okay. Crazy. Okay. Alright. So in this scenario, if I were to convert this array into a table, so it would be something like 1 1 1 2 2 2 and 3 3 3, right? So this is the rows and these are the columns. So that's what it would look like. And if you imagine it particularly, you could just like rewrite this whole thing as like array with like okay, let me just remove this. So you can imagine this whole thing as like kind of like looking like this. So you can see that there's like this particular pattern involved around this. So you can see that it kind of like makes a group of rows. So that's basically what an array in an array looks like. So let me just okay. Alright, so that's basically what that looks like. So in this case, if we wanted to declare this array, we could do something like declare values array 1 2 3 1 2 3 of integer. Or if it was, let's just say add another value, let's just add like 1 2 3, another 1 2 3. Okay, we could do something like okay, so let's just add another 1 2 3 1 2 3. So you would now do, instead of that, you would do something like 1 2 4, because there's 4 rows and then 3 columns. Okay, so if you think about it logically as well, you can see that the first thing is just going to be the length of the array, of the main array. So you can see there's 4, so it's 1 through 4, and then the second one is going to be the length of the mini arrays inside of that array. So yeah, that's basically how you declare a two-dimensional array. Okay, then you have accessing these arrays. Okay, you have accessing these arrays. Now, accessing these arrays is as simple as what do you say? Okay, so accessing these arrays is okay. So accessing a 2D array looks something like okay, it looks something like values 2 comma 3, for instance, or 2 comma 4, actually no, 2 comma 3. This would go to the second row and third column, so this would return something like 3. Okay, so it's basically array name row column. Okay, that's how you access a two-dimensional array, a value in a 2D array. And similarly, you assign it accordingly. So values 2, 3, you could assign this as 3. Okay, or you can just, yeah, that's how you assign the values. So besides this, now what you should know is filling up or initializing arrays, and that would be the last part of this entire chapter. So uh, filling up a 2D array or a 1D array. 1D array. Alright. So let's say that you have a 10x12 array. Sorry, no, not a 10x12 array. Let's say you had an array of. So let's assume that you have an array of length 10, and you need to initialize it with 0. So what you're gonna do is you're gonna make the code base for that. So first of all, you're gonna declare the array, which is going to be array. So I'll just write it as which is an array 1 through 10 of string. Sorry, of integer. The next thing that you're gonna do is you're gonna loop in it. Okay, so you're gonna go for I 1 to 10, because we established that it's what do you say? It's 10 long. So next you're gonna do what do you say? I is gonna be 0. Alright? And then you just do next time. Or if it was, for instance, you wanted to do empty spaces, you would have gone something like string, and then you would have just done something like this. Okay, so it's initialize it with an empty string. Filling up a 2D array, on the other hand, is a tad bit more complicated. So in the case of a 2D array, or looping through any 2D array for that matter, of length 10x12, for instance, so 10 rows, 12 columns, 1 colon 12. So first of all, you're gonna loop through all the rows. So I'll just mark this as an R, and then you're gonna loop through all the individual columns. So for C1 to 12, and then you're going to assign the value to it. Okay, so it will be something like Oz RC. That's how you initialize a 2D array. Right, now, or you loop through any 2D array. Looping through any 2D array, that's going to look like this. And with that, we can conclude chapter 8 and the session. I genuinely don't know why you guys are annoying Avina in the chat. That is a very weird thing to do. I swear to God, tomorrow when you open the paper and you don't get shit, you have yourself to blame. Okay? If you weren't focusing on the session, if I was just sitting here beating my ass off for no reason at all, and you open the paper tomorrow and you don't understand anything, that's on you. Okay? That's not on anybody else. That's on you. Besides that, okay, so let's do like 2 past papers and then we're gonna conclude this. Okay, let's do, okay, alright, so, okay, we've basically concluded all of chapter 7, 8, 9, 10. Yeah, I know my stream is off. I'll turn it back on. But yeah, that concludes the entire session. And okay, so okay, with that, I think we can like completely conclude ALCS. So I'll stop record. Okay, never mind, we're gonna record. Okay, so let's move on to the past papers, and yeah, let's do some past papers. Let's do 2 years worth of past papers, and then we're going to conclude the entire session. Okay, so let's go over everything one last time. So that is basically it, and I'll close the notes now, and let's do some 2 random past papers. Okay, so let me just download any past paper suggestions, any specific past papers that you guys have. One I'll do like May, June 24, the hard one, the one that I gave. Okay, May, June 24, 2-2. So computer science, May, June 2024, paper 2-2. If you guys have any suggestion, tell me. I will Okay. All right, let's just do 2 2 and 2 3. Okay, perfect. We're gonna do both of them. Okay. Okay. Let me just. Okay. So, uh, let's do 2 2 first, and then we're gonna move on to 2 3. Okay. So let's just. All right. So let's me share my screen. So we're gonna be done within like the next 1 hour, I believe. So let's do two past papers, and then we'll conclude the entire session. Okay. So is my screen visible? All right. So let's do this. Okay. Let me just change the OBS recording as well. Let's see how many of you guys are AFKing right now. I'm out of curious. If you are here, react with a check mark. I want to see how many of you guys are AFKing right now. If you have extra time, could we also do some extra truth tables? We're gonna go over all of it in the past paper, so don't worry about it. Okay, so let's okay. It's about half of you guys, which is very nice, very good. Good job, guys. Okay, so let me just change the OBS note, OBS recording as well. Okay. Do we use double signs? No, you don't use double signs. You use single signs. Don't make the mistake of using double signs. Okay. Ouch. Let me delete this and let me add a new capture. Okay. Let me just end the previous recording.